Hello everyone, welcome to Brain Puts Audios. Today, in this episode of Mind Maps, we're going to be looking at the chapter Chemical Reactions and Equations. This is the very first chapter in the chemistry syllabus for grade 10 students in CBSE. Now, this chapter is the basis for all the other chapters that you'll be studying in grade 10, and so therefore it's very important that you understand this chapter. In order to prepare for this chapter for examinations, there are various ways in which we can do it. One of the best ways to do so is with the help of a mind map. Mind maps are very useful for last-minute preparations for the exams. However, they can be quite extensive, and that's why this video is devoted to explaining them in some detail. So, chemical reactions and equations. So, what is a chemical reaction? A chemical reaction is a process in which original substances lose their nature and identity to form new substances with different properties. So the definition of a chemical reaction is a process in which original substances lose their nature and identity to form new substances with different properties. These occur due to the breaking of chemical bonds of the original substances and the formation of new chemical bonds which lead to new substances. The substances which take part in a reaction are called reactants, and the substances which are formed after a reaction are called products. And chemical reactions include digestion, respiration, corrosion, combustion, etc. So in this particular chapter, we're going to be looking at reactions, how we represent reactions, how do you identify a reaction, and then we'll be looking at the types of chemical reactions and some of their effects in daily life. So, let's move on to reactions. Chemical reactions are characterized by various changes. For example, change in color. So if you have, if you insert an iron nail into a solution, in your aqueous solution of copper sulfate, you'll find that a change in color takes place. So that means that a chemical reaction took place. Change in state. Hydrogen reacts with oxygen to form water. Hydrogen and oxygen are gases, while water is a liquid. And temperature is also an important indicator. You either find that the temperature has reduced due to it being an endothermic reaction, or it has increased due to being an exothermic reaction. So, we've learned a lot about reactions, but what are equations? So, equations are basically a representation of chemical reactions in written form. So, in a chemical equation, the left-hand side is made up of reactants and the right-hand side is made up of products. So, every reactant, the number of reactants are joined together by a plus symbol, so that represents the reactants combining together to form products. And the arrow, we always put an arrow in order to show the direction of the reaction taking place, and the right-hand side contains the products. And for example, you can see 2Mg plus O2 gives you 2MgO. These are the reactants, this is the product. The arrow shows the direction of the reaction, and the plus sign indicates that these reactants combine together. Now, Equations are told to be the simplest way to write the chemical reactions, and among equations you can write equations using words, or you can use form equations. This here is an example of a form equation. So in a form equation, you can write magnesium plus oxygen giving you magnesium oxide as Mg plus O2 gives you MgO. So these are the forms, the chemical notations of each of these elements and compounds. Now the reaction, that equation that we wrote on the right, Mg plus O2 equals MgO, is unbalanced. This is what we call a skeletal equation. The reason being that there's only one magnesium atom on the left-hand side and one magnesium atom on the right-hand side, but the number of oxygen atoms has reduced from 2 to 1, and this does not occur. The reason being that there's always the law of conservation of mass. So the law of conservation of mass states that mass cannot be created nor destroyed. So you cannot create or destroy atoms. So, at least in grade 10, that is. So, how do you write the correct equations? Well, the correct equations are usually balanced, and that's what we're going to find out. Balanced equations. So balanced equations are equations where the reactants and products are both balanced. So there is, for in this case, 2Mg plus O2 gives you 2MgO is a balanced equation. So in this particular case, there are 2 magnesium atoms on the left-hand side, 2 magnesium atoms on the right-hand side, 2 oxygen atoms on the left-hand side, and 2 oxygen atoms on the right-hand side. So both sides are balanced. The balanced equation follows the law of conservation of mass. Mass cannot be created nor destroyed. The number of atoms on both sides remain the same. And usually when we are balancing equations, you write elements with maximum atoms and then balance them first. Another thing about balanced equations is that they usually contain the physical state of the elements. So we write gaseous, liquid, solid, and for compounds which are dissolved in water, aqueous. So these are the important things that you should keep in mind when you're talking about balanced equations. So any equation, any skeletal equation can be balanced by the hidden trial method. So you put in numbers and count the atoms on both sides, and when they are satisfied, when the number of atoms are equal, then you have a balanced equation. But also don't forget to put in the physical state of every reactant and product. Now, besides balanced equations, chemical reactions also undergo thermochemical changes. So these are basically changes in temperature. Now, in some reactions, there are cases where you feed energy to the reaction, and then the reaction absorbs it, and then the energy gets absorbed. Those kinds of reactions are called endothermic. On the other hand, you have reactions where energy is released. This is known as exothermic. So endothermic reactions are used when you have to, decompose a reactant to many products. And exothermic reactions are used to combine reactants to form a product. These are usual cases. Now, enough talk about balanced equations. Let's look at the types of chemical reactions. This is the main part of this particular chapter. So you're going to be talking about various kinds of reactions and their examples and so on. So first of all, we have the types of chemical reactions based on heat. So we have exothermic, this amounts to heat released. Endothermic, this amounts to heat absorbed. Now, beside that, we have other types of reactions depending on how the elements behave. For example, we have combination reactions. Combination reactions are reactions where addition of 2 elements or compounds synthesize a new compound. An example for this will be the formation of carbon dioxide, the burning of coal. Carbon solid plus oxygen in gas gives us carbon dioxide, which is a gas. So this is a prime example of a combination reaction. Another example is the formation of water. 2H2 gas plus O2 gas would give us 2H2O. Again, all of these equations here are balanced. Water is liquid, hydrogen and oxygen are gases. Now, combination reactions are mostly exothermic. There are some reactions which are both combination and endothermic, but most reactions are exothermic when they are combining two reactants to form a product. The next type of reaction is decomposition. What is decomposition? Decomposition reactions are reactions where one reactant decomposes to form two or more than two products. Now, decomposition can happen in various ways. You can decompose elements by heating. This is called thermal decomposition. And the example for this is the decomposition of calcium carbonate. So CaCO3, which is a solid, in the presence of heat, turns into CaO, solid, plus CO2, gas. Another type of decomposition is electrolytic. So electrolytic reactions, electrolytic decompositions are those where an electric current is used to decompose a compound. For example, electrolysis of water gives us hydrogen in gaseous form along with oxygen in gaseous form. A third type of decomposition is what we call photolytic decomposition. This means that using sunlight, an element can be broken down into its compounds. And a classic case for this is silver chlorides and silver bromides. Both of these compounds, when kept in the presence of sunlight, which can be represented as H nu, breaks down into silver and the respective halogen. In this case, it's silver and chlorine. And that's why photolytic decomposition is such an important part, because it's used in photography. It used to be used in photography where you had to prepare films. So, decomposition reactions. So how is their heating? So how do they heat themselves up? Well, the important thing is that most of the decomposition reactions are endothermic. So that means they usually absorb heat that is provided to them by heating. For example, on a burner or in the sun or in an oven, for instance. So the types of chemical reactions do not end here. We still have to discuss other types of reactions. And the next in our list is displacement reactions. So in a displacement reaction, a more reactive element displaces a less reactive element from its salt solution. And an example for this is the displacement of copper from its salt solution. For example, iron, when it reacts with aqueous copper sulfate, it forms iron sulfate, which is aqueous, and solid copper, which is a precipitate. So copper sulfate is blue and iron sulfate is a dirty green, so you can easily observe this reaction. So as you can see, iron, being more reactive than copper, displaces copper from its salt solution. Now notice that these kinds of reactions are dependent on the reactivity series of metals and also non-metals if they have, because they do have a reactivity series as well. So all kinds of reactions are dependent on this reactivity series, but displacement reactions are more so, because here you need to have a comparison between a low reacting element and a highly reactive one. The next kind of reaction are double displacement reactions. So double displacement reactions are reactions where new compounds are formed by mutual exchange of ions between the two compounds which are present. So the two reactants exchange their ions to form two new compounds. And an example for a double displacement reaction is the precipitation of BaCl2, BaSO4. So Na2SO4, sodium sulfate, which is aqueous, reacts with barium chloride, BaCl2, again aqueous, and this gives us BaSO4, which is solid, plus NaCl, 2 times of NaCl, because we're balancing it, which is aqueous. So in this case, the sulfate ion is taken by barium, and the chloride ions are taken by the sodium ions. So this is how double displacement reaction works. And again, they do depend on the reactivity series, because metals that are less reactive do not undergo any type of reaction, but then they're not as dependent as single displacement reactions are. And now we have oxidation and reduction as the final types of chemical reactions that you will study. Now, oxidation is basically defined as reactions where you have addition of oxygen and removal of hydrogen. So let's erase the arrows and write again. Addition of oxygen and removal of hydrogen constitutes oxidation. And addition of hydrogen and removal of oxygen, they constitute reduction. Now remember, these are just basic definitions. They're not, oxidation and reduction are not just limited to these two events. There are other cases where we can classify reactions as oxidation and reduction, but more on that in your higher grades. An example for oxidation is the formation of copper oxide. So 2Cu plus O2 gives you 2CuO. So here you can see that oxygen is being added. So this is an oxidation reaction. For giving you the example of a reduction reaction, that's the formation of copper from copper oxide using hydrogen. So CuO plus H2 gives you Cu plus H2O. So as you can see, the oxygen gets removed in this scenario, and that's why this is called reduction. So oxidation and reduction can happen in different reactions, but they also can happen in the same reaction. And when they happen in the same reaction, we call them redox reactions. So a redox reaction is where oxidation and reduction happen in the same reaction. So therefore, that completes chemical reactions, the types of chemical reactions. Now let's look at some of the common effects that we can see which are due to chemical reactions. So when we look at oxidation and reduction, they affect our lives very much, and a classic case for this is corrosion. Corrosion is a redox reaction, and this happens due to the oxidation of metals, and the oxygen in water gets oxidized, gets reduced to oxide ions. So therefore, corrosion is a redox reaction involving the oxidation of metals, which causes damage. And examples for these are corrosion of iron, formation of a green layer on copper, tarnishing of silver, all of these are examples of corrosion. Corrosion is usually prevented by steps such as painting the metal, galvanizing the metal, using electroplating techniques, etc. And you'll study a lot about corrosion and how exactly it occurs when you study redox reactions in your higher grades. Now let's move on to another very harmful effect of oxidation in our daily lives, which is rancidity. So what is rancidity? Rancidity refers to the slow oxidation of oil and fat in foodstuff. And when oils and fats in food get oxidized, they produce a foul odor and taste, and sometimes can even be poisonous to humans when consumed. So they are unsuitable for consumption. So that means rancidity is a really important problem, and therefore there has been steps that have been taken by food manufacturers in order to avoid their food becoming rancid. So rancidity is prevented, one, by adding antioxidants. These are chemicals which prevent oils and fats from getting oxidated. Another step is to use airtight containers. So that means block air from entering. So the foodstuffs that we get, mainly processed foods, these are packed in airtight containers, and they're also filled with inert nitrogen gas. So since nitrogen is inert, it does not allow oxidation to occur inside the container. So that means the food is not spoiled. It's not turned rancid. So these are the topics, the main topics that the mind map deals for the chapter Chemical Reactions and Equations. Now, it's not just mind maps that help us to learn and revise for exams. You can also use flowcharts for the same purpose. And if you look at a flowchart for chemical reactions, you usually have a flowchart where you can see the different types of reactions, which are combination and then decomposition and its subtypes: thermal, electrolytic, photochemical. Then you have displacement reaction, single displacement, double displacement, and you also have neutralization reactions, which are basically a special case of double displacement reactions. So this is where an acid and a base react together to form a salt and water. So that's why they're called neutralization. And then we have redox reactions, which are basically the sum total of oxidation and reduction reactions. So these are the basic reactions, and when both of them occur in a single reaction, we call them redox reactions. And finally, we have exothermic and endothermic reactions. Exothermic when heat is released, and endothermic when heat is absorbed. Then you probably find flowcharts on corrosion. You'll find examples such as rusting, green layer over copper, tarnishing of silver, and then you have conditions necessary. So corrosion occurs when you have presence of air as well as water, so basically humid environments. And corrosion is really bad for the economy because tons of resources are getting wasted due to corrosion. And you'll also find a subtopic where you'll see methods to prevent corrosion by using paints, galvanization, electroplating, alloy formation, etc. So these are all processes that you can use to prevent corrosion. That concludes this episode of Mind Maps. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have, prepared a lot of videos on mind maps, especially for grade 10 students, so you can always find those in the playlist given in the description box below. And if you want to get the latest updates from our channel, then please don't forget to hit the notifications button and set it to all. So, until the next webisode, take care, stay safe, bye-bye for now.